All right, we have a triangle right here that has a base and a height that are each extended by 2 centimeters. And what we have to do is write an expression that represents the area of the shaded region. All right, whenever finding the area of any shaded region, basically what you do is you take the area of the entire figure, that would be the shaded and the unshaded, and then subtract the unshaded part from that total area, and what you have left over would be the shaded area. All right, so what we're going to do first is write an expression for the entire figure, the shaded plus the unshaded. So we would say that the base of this entire triangle from this point to this point is a distance of 10 centimeters. So we're going to take 10 and we're going to multiply it by the height of this triangle, which from here to here is x plus 2 more. So we're going to multiply the base of 10 by x plus 2. Now remember, with any triangle to find its area, we have to multiply its base by its height divided by 2. So we have to take the base times this height of x plus 2 and divide that by 2. All right, next what we're going to do is simplify this a bit. We're going to distribute this 10 by doing 10 times x, which is 10x, and 10 times 2, which is 20. And we have to divide both of those terms by 2. All right, so if we take 10x and divide that by 2, that is 5x. And if we take 20 and divide that by 2, that is going to give us 10. All right, so this expression represents the area of this large triangle right here. Now what we have to do is write an expression that represents the area of the smaller triangle. Now the smaller triangle has a base of 8 centimeters. So we're going to take 8 and multiply it by its height, which would be x. So we have 8 times x. And we also have to divide that by 2 because we're dealing with a triangle. All right, so if we take 8x divided by 2, that would give us 4x. Now, what we have to do is subtract the area of the larger triangle with the area of the smaller triangle. So we're going to take this expression, which is 5x plus 10, and we're going to subtract it with 4x. All right, so what we're going to do is combine like terms. 5x minus 4x is 1x, so we write just x. And we have a constant left over, so we just bring that down. That is x plus 10. So this is an expression that would represent the area of just the shaded section. Now, there is another expression that we could have written that would also represent the area of the shaded portion. Now, what we could have done is we could have looked at the shaded portion as a rectangle with this small triangle sitting right on the top. So if we take a look at the small triangle here, we can see that its height from here to here is 2 centimeters. And of course, the base of this triangle is also 2 centimeters because opposite sides of rectangles are equal. So if it is 2 centimeters from here to here, then it has to be 2 centimeters right here. So if we took 2 times 2, the base times the height, and then divided it by 2, that would give us 4 divided by 2, which equals 2 square centimeters. Now we're going to take this rectangle here and find its area. And to find the area of any rectangle, it's just base times height, or length times width. So let's take this side, which is 2, and this side, which is x, and just multiply them together. So the area of this rectangle right here is simply 2x. So we're going to take the area of this rectangle and the area of this triangle, which is 2 centimeters, and combine those areas together. So we're going to take 2x plus 2, and that is as far as we can go. We cannot combine those terms because they are not like terms. So one possible expression that represents the area of the shaded portion is x plus 10, and another is 2x plus 2. Now, because we came up with two different expressions that represents the area of the shaded region, that means that these two expressions must be equivalent to each other. So if we take x plus 10 and set that equal to 2x plus 2, that would allow us to determine what the value of x is. So let us go ahead and do that. So what we're going to do is we're going to take this x right here and subtract it on both sides. And that leaves us with positive 10 on this side. And on this side, that leaves us with positive 1x plus 2. Now we're going to take this positive 2 and subtract it on both sides, which leaves us with 8 equals x. So now we know that x is equal to 8. Now the problem asks us to find an expression that represents the area of the shaded region. But now, because we know what x is equal to, we can actually plug 8 into x and figure out what the actual area is. So if we were to stick an 8 right there, we would know that this rectangle here is a 2 by 8 rectangle. And of course, 2 times 8 is 16. And then this triangle right here, we already determined earlier that its area is 2. So if we added 16 and 2 together, that would give us an area of 18 square centimeters. Now, something else we should note is this. If we take this expression, x plus 10, which does represent the area of the shaded region, and substitute 8 in for x, that would give us 8 plus 10, which is also equal to 18. Now, if we took the other expression, 2x plus 2, and substituted 8 in for that x, that would give us 2 times 8 plus 2, which is equal to 16 plus 2, which is also equal to 18 square centimeters.